You know, it's something we use every single second of every day, but have you ever stopped to think about how it actually works? Well, today we're going to pull back the curtain on one of the most incredible, yet kind of invisible systems ever built, the electrical grid. We're going to trace the entire journey of power, right from where it's made all the way to that light switch on your wall. Yeah, think about it. You flip a switch and boom, light instantly fills the room. But what really happens in that split second? Behind that super simple action is this massive, complex, and honestly, fascinating journey. And that's exactly what we're going to follow, from the very beginning to the very end. Okay, and this right here, this is going to be our map. Now, I know, at first glance, it might look a little complicated, but trust me, this one diagram shows us the entire path that electricity takes. We're going to follow the flow together, all the way from that huge power station right down to your house. So our little trip here is broken down into 4 main parts. First up, we'll start where the magic happens, with the spark power generation. Then we'll hit the superhighway for high voltage transmission. After that, it's all about the final mile, or distribution. And finally, we'll see how it all comes together in powering our daily lives. All right, first stop, the spark. This is ground zero. This is where it all begins. I mean, before electricity can go anywhere, you gotta make it, right? And if we look back at our map, it shows us exactly where to start, right here at the power station. See it? It's the birthplace of all the electricity that we're about to follow on its long journey. So what happens at these power stations? Well, basically, they take some other kind of energy. Could be the heat from burning natural gas, the force of moving water in a dam, or even sunlight, and they convert it into the electrical energy that's going to start this whole incredible trip. Okay, so we've made the electricity. Now what? How do we get it from that power plant, which could be hundreds of miles away, all the way to our cities and towns? Well, that brings us to part 2, the electrical superhighway. Let's look at our map again. We're talking about this whole section right here. You see those giant towers and the super long wires? That's the transmission system. It's basically a long-haul network, and its whole job is to move massive amounts of power really, really efficiently. And right after the power station, we hit a really critical piece of equipment, the power transformers. Their job is to step up the voltage. And I mean, they crank it way, way up, sometimes to over 500,000 volts. So why do they do that? Well, it's the secret sauce for efficiency. At those crazy high voltages, much less energy gets lost as heat when the electricity is traveling over hundreds and hundreds of miles. So a good way to think about these transmission lines is like they're the interstate highway system, but for electricity. Yeah, they're built for high speed, long distances, and they can carry power clear across the country. All right, so after traveling down that long highway, the power needs to take its first off-ramp. And that happens at a transmission substation. Here, they basically do the exact opposite of what happened at the start. That super high voltage gets stepped down to a much lower, more manageable level. It's getting prepped for the next leg of its journey. Okay, so the power has made it to our region, it's off the highway. Now it's time for stage 3. We're talking about the final mile, navigating through our local neighborhoods. If we look back at our map, this is the distribution network. And these are the power lines you see every day. You know, the ones on those familiar wooden or metal utility poles that line our streets. The electricity is officially off the highway, and it's making its way down the local roads. And you can really see the difference in scale here, right? If transmission lines were the interstate, then these distribution lines are like the grid of local streets and avenues that wind through our neighborhoods. Their job is to make sure that power gets to every single house and business. But wait, before it can go down those local streets, the power has to make one more important stop, the distribution substation. This is where the voltage gets stepped down one last time, taking it from that regional level to a level that's actually safe to be delivered right into our homes and businesses. And that brings us to the final destination, the end of the line. This is the part where all of this incredible, complex engineering finally meets our everyday lives. So let's take one last look at our map. You can see the end users right here. This represents, well, everyone. We're talking about large factories, big office buildings, and of course, residential homes, just like yours. Now, the grid has to serve a bunch of different kinds of customers. You've got your commercial and industrial users, think big factories and office buildings. They need a ton of power to run all their heavy machinery and large-scale operations. And then you have residential consumers, like you and me.
We use that very same power for, our lights, our TVs, our refrigerators, all the comforts of modern life.
So really think about this. The next time you plug in your phone, just pause for a second and remember this whole journey. That little bit of electricity has traveled hundreds of miles, its voltage has been stepped up and stepped down multiple times, and it's navigated this incredibly complex web of wires, all just to get to that little charging block in your hand. The journey is finally complete. So, let's do a super quick recap of the whole trip in 4 simple steps. Step 1, generation, where the power is made. Step 2, transmission. That's the long-distance superhighway. Step 3, distribution, which is the local delivery through our neighborhoods. And finally, step 4, consumption. That's us using the power. You know, this basic system has been powering our world for more than 100 years. It's pretty amazing. But as we move into a future with more renewable energy, tons of electric vehicles, and all sorts of smarter technology, it really makes you wonder, doesn't it? How is this incredible century-old grid going to have to evolve